Okay, so now we're going to continue our worksheet on um, S10H.1 exponential models. And where we left off was right here. So let's just do one example, and then you need to do this on your own, and I'll put on my answers for you to check your work. So if I have 3 to the power of x, and I graph it, okay, so notice my window is like it was for the previous example. If you want a standard window, you can hit zoom, and notice here it says for Z standard, if I hit 6, then I get a standard 10 by 10 window. And then that's going to give me a smaller graph here. So, and if I hit second graph to get my table, I can see that at 0 we cross at 1. And when x is 1, we're at a value of 3. And as you saw before, it's increasing. So these two values are probably the most important values for our graph. And we did 0.5 on the previous page. Let's do this one here. 2 to the power of x, and then over here plus 3. And from our investigation number 10, we learned that this is going to create our horizontal asymptote. What do you think our horizontal asymptote is going to be? And make a guess what you think this line is that it's approaching here. After you've made your guess, you can go over here and you can see it's getting closer and closer to 3. It never actually gets to 3. It gets closer and closer and closer and closer and closer and closer to 3. Now it says it's 3 because the calculator can only function so much. But it doesn't actually ever equal 3. So our graph looks like this. So as I said, the most important thing is that you get the y-intercept and the first value correct. So the y-intercept here when x is 0 is 4. Okay, where did the number 4 come from? Why is it 4? And when x is 1, we're at 5. So for when x is 1, let's talk about the y-intercept first. Okay, so here we've got 2 to the power of 0 plus 3. So anything to the power of 0 is 1, so I've got 1 plus 3, which gives us a value of 4. And here, as we did before, we have 3 to the power of 0, and anything to the power of 0 is 1. And that's why it crosses here at 1. Okay, so it's important for you to try the next ones on your own and then fill out the table. Okay, hit pause and try this on your own. Okay, now that you've tried this on your own, I want you to check your graphs. And as I said before, the most important thing is that you've got the y-intercept correct, that if it's growth or decay, and okay. And then as you do this, you should fill out your table. Please check your table. And we're going to be looking at our y-intercepts and our asymptotes here. So notice, whatever the value of c is, now c is this value here that we're adding by itself, okay? And whatever our c value is, notice that gives us our horizontal asymptote. They're the same values. And you should have seen this when you typed this into your calculator. Now our y-intercept, you should notice, here it's at 1, here it's at 1, here it's at 4. Okay, how did we get 4? And I mentioned before that when x is 0, this is a value of 1, and then we already have this plus 3, which gave us 4. here we have a value of -1, here we have a value of 3, here we have a value of -1. And what you should notice is that, what did we do before? We added 1 plus 3 to give us 4. Here you should notice that if we add 1 plus -2, we get -1, and so on. Because 3 plus -2 is going to give me 1. Okay. So, what you need to do is to answer these questions on your own. You should hit pause, and then we're going to discuss these, the answers to these. Okay, so now that you've tried this on your own, so what is the connection between the value of C and the horizontal asymptote? So the horizontal asymptote happens when the equation is equal to C. Now, what is the connection between the K and the C coordinates of the y-intercept? And as we found out, that K plus C gives us the y-intercept. So K plus C gives us the y-intercept. Okay, what is the connection between the value of A of our function, whether it's increasing or decreasing? So when A is greater than 0, it's increasing. When A is less than 0, it's decreasing. We kind of had the same question on the earlier page. Okay, describe how you can decide whether a variable is independent and which is dependent. So we're going to start off with x being dependent, or independent, sorry, which means x can be whatever we want. You can pick any value of x, and then we can, and so if we pick any value of x, we can change x, and then that gives us our y value. So since y changes depending on whatever we have x, then y is dependent on whatever value we choose for x. Okay, what does the horizontal asymptote represent? How can you decide if a function has a horizontal asymptote? Okay, so the horizontal asymptote is a boundary line that the equation will never cross, and we've kind of investigated and seen that. If the graph approaches the value but never crosses it, that's when it has a horizontal asymptote. Okay. And then what parameters of an exponential function? So the parameters of an exponential function are a times b to the x. Actually, we used different letters. We used k and a and c. So okay, so let's change this now. So k is the starting point when x is equal to 0, and okay, well, I only did this. Let's do this how I originally had it here. So if I have y equals a times b to the x power, so whatever this initial value is, it would give us our starting point when x is 0. When we add c to this, we end up shifting it up and down. The parameter b represents if it's growth or decay. We've already talked about that. And when we have our negative x power, it's going to be decay. Okay. Explain the difference between growth and decay. With growth, it increases. With decay, it decreases. Okay. Next page. Okay. So the next page summarizes what we've been doing. The equation of the horizontal asymptote. So what we're going to do, without doing the graph, we're going to try to see if we can remember everything that we've done. So remember that y equals k a to the power of x plus c. So we've got our y-intercept is when x equals 0. Right? And so when x is equal to 0, this a plus x, it would be equal to 1, so it would go away, and we end up with k plus c. So the y-intercept is equal to 0, comma, k plus c. Okay, and the coordinate of where it cuts the x-axis. So, so it cuts. Oops, I did that backwards. That's for II, the y-intercept. Sorry. Cuts the y-axis at the y-intercept. Okay. The equation of the horizontal asymptote. So we learned on the previous page that the horizontal asymptote is when not x, when y is equal to the value c. And state whether it's increasing or decreasing. That depends whether a is greater than 0 or less than 0. Okay, so you may want to look at the previous page to help you answer these, and let's talk about the answers. Okay, so now that you've done your work, our horizontal asymptote happens at this value here. Uh-oh, notice there's no value here, so it's going to be at 0, right? And our y-intercept is going to be, notice there's no number in front of the 3, so it's going to be 1 plus 2, which is going to give me 3. Here we've got a 5. Our k value is 5, and our c value is -3. So 5 plus -3 is going to give me -2. So here, there's no k value, so k value is going to be 1. So we got 1 plus 1, which is going to give me 2. Notice there's no k value, so k value is going to be 1. Here, k value is going to be 1. 1 plus -3 is going to give me -2. And there's no c value, so it's just going to be 1. Okay, we haven't really talked about domain and range yet. So the domain is, you can put any number in for x, so the domain is all real numbers for all of these graphs. Okay, and let's talk about the range. So on this graph here, let's just type in this one graph, or let's look at our previous graphs. For all of these graphs, notice they're all above the c value. They're all above the asymptote. So here, our asymptote is at 1, so the range is y is greater than 1. Here, my range, our asymptote is -3, so y is greater than -3. Notice I didn't put an equal sign under the inequality because it's never going to actually be equal to -3. So here, our range is y is greater than our asymptote, which is 0. Here, our range is y is greater than our asymptote, which is 2. Y is greater than -5. Y is greater than 3. Y is greater than -1. Same thing here. Okay, you may want to check your answers. There we go.